All right, now we're into chapter 2, kinematics. And the first point in kinematics is understanding displacement. All right, so displacement is just the difference in position or how far you have moved. So here we have a teacher at a blackboard. She starts off at a position that's 1.5 meters, moves to a position that's 3.5 meters. That gives her a displacement of 2 meters. Sorry, the 2 meters is just the difference between her final and her initial position. How far are you away from where you live? That's your displacement when you come to campus. Now, the total travel time, or the total travel distance, total travel distance may be different. Just like if this teacher starts off the lecture right here and ends the lecture right here, her total displacement, right? Her total displacement is 2 meters. But during that time, she's walked back and forth and back and forth and back and forth and back and forth and back and forth. So sometimes she heads this way, sometimes she heads that way. Or if you were in the streets of Cleveland and you're going in a grid, like most of the streets in Cleveland do, your displacement depends heavily on all those turns that you make. And what we're really talking about, right, if you start, say, here, I'm going to go this way and this way and this way and this way and that way and that way. Well, your displacement is really just, oh, let me do that all over again. All right, so here we are. We're going to start, we're going to go, we're going to go, we're going to go, we're going to go, right? And you end up here. Your displacement isn't the total distance you've traveled, all right? Your displacement isn't the total distance you traveled. Your displacement is the distance from here to there, right? It's that distance. That brings us to the next part of displacement, which is vectors. Well, coordinate system matters, right? East we typically think of as positive x direction, west is negative x direction. That's a bias we have here. Northern hemisphere. They probably have the same bias in the southern hemisphere. North and south tend to flip though. So you drive 3 kilometers, just as I was saying, 3 kilometers to the west, 2 kilometers to the east. Your total displacement is just 1 kilometer to the west, right? So when we talk about displacement, we're talking about something we call a scalar, right? It's a scalar. It is the distance you are from the point of your origin. Now, what complicates this is that there are also vectors. Vectors have both distance and direction in them. And when we talk about scalars, when we use a sign on a scalar, plus or minus, we're actually using a vector because we're talking about one direction on the number line or the other. All right, so scalars, no direction. So 1 kilometer, 10 kilometers, 35 kilometers per hour, those are all scalars because they don't have directions. To get a vector, you need to take a scalar and pair it with a direction. All right, so vectors, east, north, south, west. I walked 1 kilometer east. I am traveling 35 kilometers per hour north. Those are vectors because they both a scalar component and a direction, right? Now, usually we're just going to call the directions the x direction or the y direction, and we'll use little unit vector notation x hat or y hat, this little thing right here, x hat, right? That little cap on top of it is what we're calling the hat. So to really understand where you are, you need both the scalar component and the vector component. To just say Ruleville is 10 miles from here or 11 miles from here doesn't help you as much. That's not all the information you need. Ruleville is 11 miles east of here, right? That has the complete information in it. So when you need a vector, it's both a scalar number and a direction. We will use unit vector notation all the time. A unit vector is just a vector with length 1, and we'll use a unit vector along the x direction which we'll call x hat. Sometimes we'll also use I hat for this, and so we'll use x hat, y hat, z hat, and we'll use I hat, j hat, k hat to indicate the x, y, and z directions on an axis. Unit vector has no unit, so we can use it for anything, right? 10 kilometers in the x direction is 10 kilometers x hat. 13 kilometers per hour in the x direction is 13 kilometers per hour x hat, or 13 kilometers per hour I hat. And we will in lab, and this is not a lab, it's in our lab book, we will in lab be doing some extra vector work this week. All right. So all three directions, right? I, j, k, which are x, y, and z. And these are our unit vector notation for these three directions. X, y, z, or I, j, k. All right. That's it for this topic.